you see question 17. They give us a polynomial which is power to 4. And we are missing value here. The coefficient here we're missing A, B, C, D are constant. They said had a factor. As a factor means our polynomial will equal to 0. When x equals to x plus 2 is a divisor means x equals to negative 2. That will be our first factors theorem. And then they said there has factors for this x plus 2 and x minus 1. So at the same time, when x equals to 1, our polynomial will equal to 0 also. Both of them are factor theorems. And they give us another information. They said when you divide by this x plus 1, so your value of x here is negative 1, it has a remainder. Remainder is 8. It means our polynomial will equal to 8. So find the value of ABC. So we have 3 unknown here. So of course we'll need to have 3 informations. And then after finding this AB, only we factorize it completely and state out its zeros. Okay, so first of all, we write our theorems first. The first theorem here is factor theorem where x equals to negative 2. So we substitute when our divisor is x plus 2. So the value will be x equals to negative 2. Substitute into the polynomial. Because it is a factor, it will equal to 0. Because they said this divisor is a factor, so we let it equals to 0. So write this theorem. So this is our factor theorem. Px equals to 0. So then only we substitute our value 2 into the equation here. It will be 32 minus, substitute here, negative 2 cubed become 8. And then negative 2 square become 4. And then here negative 2 will become positive 34 plus c, which is equals to 0. And then we try to simplify. We will have 8a minus 4b, then minus c. So put out the value and move it to the right hand side. Remove the negative, divide by negative. That will be our first equation. So hold on first, because you have 3 unknown. Of course, you will have 3 simultaneous equations. So that will be our part 1. So repeat again for this another factors. So when x minus 1 means x equals to 1, it is a factor. So when I substitute this x equals to 1 into polynomial, it also will get 0. So we start out, substitute 1, we get 2. Okay, so this is our equation. Substitute 1 become 2, then 1a, 1b, negative 17 plus c. Then third information, when your polynomial divide by x plus 1, so your x here is negative 1. You get a remainder 8. So this is a remainder theorem, means when you substitute negative 1 into our polynomial, it will equals to 8. So actually polynomial is like a function. When we study our function, we have linear, we have quadratic, we have cubic, we have power 4, and so on. So actually polynomial is a sub-function there, but from the chapter 5 there, apart from that. So we substitute our negative 1 inside. What we get here, we get 2. And then minus a plus b plus 17 plus c equals to 8. So we simplify it, we rearrange, it will be a minus b minus c. I remove the negative together. So I get 3 simultaneous equations. Because I want to find for 3 unknowns, so of course I will have 3 simultaneous equations. Okay, so how we going to solve this simultaneous equation? We must able to eliminate our unknown. So you see unknown here got 8a 4B, 1C. Here 1A, 1B, 1C, here 1A, 1B, 1C, but it's negative, so we can simplify here first. When we simplify these two equations, we can eliminate B and C together. Because we take 2, when we take 2 plus 3, B and C will be eliminated, then we get to find A. So from equation 2, 3, I will take equation 2 plus 3, then I will get 2A. Then B minus B finish, eliminate. Then C minus C also cancel, eliminate. So I get the unknown A. So 15 plus 11, we get 26. So we get first constant A here is 13. So once we get a first constant A 13, we still have B and C. So we have to substitute our A and build up two simultaneous equations because we have B and C haven't found yet. So of course these two simultaneous equations are same, so we cannot reuse it. So we use this equation 1 or either one from here. Because they eliminate B and C together, so I only will choose one of them so that it remain BC difference from this. So from here, we substitute our 13. In order to get new equation involving BC only. So 104. Here is 104. When you move to the right hand side, 66 minus 104. So it will give you, substitute into A, it will give you negative 4B, negative C equals to negative 38. Equation 2 dengan 3 tak sesuai dah sebab dia similar tau. Dia hanya nampak A yang berbeza. So bila kita operate equation 2 dengan 3, dia automatic matikan BC sekali. So saya kalau saya masih lagi guna equation 2 dengan 3 untuk cari BC, dia akan mati serentak BC tu. So saya kena cari equation yang lain supaya dia tak matikan serentak BC. So saya masukkan A, saya pilih equation 1 atau dengan equation 2, equation 1 atau dengan equation 3, so that dia tak matikan serentak BC. So we substitute our A into 13, we get this. So we choose either one. We won't use these two because these two are similar for BC, so I cannot find out the equation in BC difference. So I choose, let's say, equation 2. When I substitute A into equation 2, so 13 plus B plus C, so B plus C equals to here 13. I move to the right hand side, so it will get 2. So we can see we have now we have two equations involve BC which are different, where we can eliminate C. When we can eliminate C, we get B, then automatically we substitute B, we can get C. So this is our equation 4. This is our equation 5. And then we will plus 4 plus 5. C will be eliminated. Okay, so writing mistake, substitute into 2. Okay, so adding it together, so C will be eliminated. We can find B. So either one to be eliminated, we can find the remaining one. So the balance one here, negative 4B plus B, we get negative 3B. So when you plus together here, negative 36. So B will equals to 12. Then finally, take the B equals to 12. We sub into equation 5 here in order to find out what is our C. So 12 plus C equals to 2. C equals to negative 10. So this is our A, B, C. how to solve these three simultaneous equations. So we look at the marks here. So concept how we use factor theorem and build out all these equations. We have three equations: factor theorem, reminder theorem. So of course this one K is evolving also at here. How we substitute our theorems and getting the equation, three equations together. So then the first part we solving A and then get two equations simultaneous. So this marks is for your solving simultaneous equation and get to answer. So our answer here, I rewrite the answer. Finally, A will equals to 13. Conclusion, B equals to 12. C equals to -10. Okay, so that will be our first part, finding ABC. Okay, we will continue. So you look at, they say hence. So when it comes from hence means we have to use our information before that. This is our information that we have in first part here, A, B, C. So use this A, B, C. We have to factorize this polynomial completely and take out the zero. So we have to factorize it. How to factorize it? We divide by its factor. So when you divide its factors, you can get another factors. So I take the polynomial first. Our polynomial here. When we substitute A, B, C here, it will become 2x4 plus 13x cubed. So how we factorize it completely? We divide by its factor. For this polynomial, we have two factors here. So we divide together. So our factors here, given, it is, we have 2, so there are x plus 2 and x minus 1. X plus 2, x minus 1. So basic concept, when we have quadratic, we have two factors. When we have cubic, we will have three factors. When we have polynomial power for automatic, we will have four factors. So this is like common knowledge. Alright, so we will divide together with these two factors together. So when I want to divide it, I expand what is the quadratics here, so that I can do the long division easily. Here is x squared, then minus x plus 2x plus x minus 2. So this factor will become our divisor. Alright, because your polynomial will equals to your divisor times your quotient, then plus your remainder. So for factor, means your remainder will be equals to 0. So all this is your factor, your quotient is your factor, your divisor is your factor. So you divide by your divisor factors here, you can get other factors. So we take this polynomial, 2x power 4 plus 13x power 3, and do our long division. Divide by these two factors. Okay, so how to do this long division? We will multiply to a value so that this polynomial leading term here will be cancelled. So how to cancel this 2x power 4? 2 divide by 1. We need a multiplier of 2. We need a multiplier of 2 so that I get 2x. So how about to get x4? So x4 divided by x2, I need a multiplier of x squared. So I expand back to other term. 2x squared times x squared will become 2x4. So you can see this one managed to divide. So for other term, just follow through only. So 2x squared times 2 become 2x cubed, and then 2x squared times -2. Then we see the balance here. What is remain here? So minus. So minus of this one, finish, managed to divide. So for this minus, you will get 11x cubed. And minus negative 4, it will become plus. Negative, negative become positive. So for others, if you don't have anything, means 0, then we repeat the process of division until the power of this remainder is less than the power of divisor. So cubic still higher than quadratic, so still can do the division. So what's the multiplier I need here to get 11? So I will times the constant 11 to get x cubed. We will times the x here. So 11x times this x squared. Automatically we can achieve 11x cubed. So later on this one managed to divide. So for other terms, we just follow expand like usual. 11x times x. Here 11x squared. Then 11x times negative 2. Then we minus. See what is a what's a balance here. We minus, balance no more. We minus here. Our balance leaving 5x squared. Then we minus here, negative, negative become positive. Then negative 10 minus. So we still can carry on our divisor because they are same. Quadratic, quadratic, they are same ranking. They still can divide. So what can we do? How to get this 5x squared? So I need time a 5 here. So I need a constant 5 here, so that when I expand downwards here, you will get 5x squared. Continue for other terms, 5x. So you can notice that when we divide by our factor, we won't have any remainder. Our remainder here is 0. Okay, so it means that our division is correct. When we're doing the division with our factors, we get all the factors. So here, our conclusion here, our polynomial divisor is our x plus 2, x minus 1. This is our divisor in factor form because the question asks us to do factorize completely, means put all the things in the bracket. Don't put in the expanded form here. So put in factor form. So its original factor form is this x plus 2, x minus 1. Our quotient is a quadratic 2x squared plus 11x plus 5. Remainder, don't have remainder. So factorize it completely means this quadratic, we have to undergo factorize again. For quadratic, we can factorize using calculator. So you can get your value. So you can try factorize here. Your 2x, x, I think 1, 5 is here. So 10 plus 1x. So if you press your calculator, factorize x squared, you can get negative 1 over 2. Then you know your factor is 2x plus 1. When you get x equals to negative 5, then you know your factor is x plus 5. So this is our meaning of factorize it completely. So you can see polynomial power to 4, it will have 4 factors. Polynomial quadratic, you will have 2 factors. So polynomial power of 3 will have 3 factors. So that will be our part of factorize completely. State is zeros. So state up is 0. So this is factor. If you're writing your x, it will be our roots. Like this one, x equals to negative 2, x equals to 1, x equals to negative half, x equals to negative 5. This is not 0. This is what we call roots. So they didn't ask us for roots, so don't do this. Okay, they want zeros only. Zeros only means we take this value only. So the zeros for this polynomial are negative 2, 1, negative half, negative 5. So writing without x, then only we call it 0. So if you're writing with x together, then will be wrong because that is roots, that is not zeros. So I will continue for the marks. So this is the concept. This is a concept where polynomial divide by your factors, you can get quotient. So from that quotient, factorize again to get all these factors. Lastly, just state out our rows. So it will be total in 9 marks.